In this video, we're going to be taking a look at the gauge group SU2 and visualizing how the basic Pauli spin matrices operate on vectors in C2. SU2 is defined as the unitary matrices of operating on C2, which is the Cartesian product of two complex planes. It's a set of unitary matrices. So unitary means, first of all, that the modulus is 1 and so the distance is preserved in this. So let's take a look at a copy of C2. One way to visualize this is to just consider two copies of the complex plane right next to each other. And so this first copy of a generic element of C2 written as a simple vector, AB, can be written something like this. You just, A is, say, right here, it's some vector in C. Obviously, the horizontal parts are the real and the vertical parts are the imaginary parts. And then B is some generic vector, perhaps down here. So what do these spin matrices do? What do the generators of SU2 do? Well, sigma 1, sometimes aptly called sigma x, written as 1/2, 0, 1, 1, 0. What does this do? Well, this is the easy one to visualize because it's going to take, when you operate sigma x on AB, the elements in the matrix are just going to serve to flip the numbers. And so when you start off with C2 looking like this, sigma x is going to take C2. B will now be put on the first side and also scaled by a factor of half. And then A will be on the right side. That is what that's what sigma x does to this initial vector in C2. What about sigma y? Well, sigma y is, again, with the 1/2, it's 1/2, 0 minus I, 0. And so if you consider that, if you consider AB now, now we're not just multiplying it by 1, but we're multiplying it by I and minus I, and those both signify rotations in the complex plane. So we're going to have so in the first part of C2, the B vector, which was on the second part of C2, is now going to be put on the first part. But in addition to that, right, this is what it started off with. A multiplying by minus I signifies a rotation by pi over 4, 90 degrees. And so it's going to go up right here. So this will be the resulting vector in minus IB, and it switches planes. And then I, multiplying by A, now that's the simple rotation by pi over 2 that we're familiar with. And so A will, starting off kind of right here, A will rotate that 90 degrees as well. And so this will be IA. And so this is a helpful way to visualize what sigma x and sigma y do to this generic vector in C2. The final spin matrix that we're familiar with is sigma z. And sigma z, that will take the sigma z, when you write it out in its normalized form, it's 1 minus 1, and with zeros in the diagonal entries now. And so that is going to take the A, it's going to leave A exactly where it's at, and it's going to take B and just flip it around the imaginary axis. So it'll become minus B. this is just one helpful way to visualize how rotation or how unitary matrices in C2 affect a generic element of there.